ماكو تشوفه لأول مرة ماكو تسمعه، فهذا ليس بغريب. فأني أمدح بالطالب مدح وجه الوجه إلى إنجاز هذا العمل، وبالإضافة إلى المشرف. وآخر 10 دقائق ننطي المشرف مجال حول استعمالات الباليغوسكايت في كيفية استصلاح الأراضي الملحية، أراضي الصبخة. هاي أيضا ماكو تقنية جديدة توهم بدأوا بها الأوروبيين يشتغلون بها، فإن شاء الله تكمل هاي التقنية هنا بقسم الجيولوجي وبوجود السيد رئيس القسم. أنا العفو ما رحبنا بيك ماكو، لأنه احنا ميانا صرنا وأنا أستاذك، فاستغليت هاي. فتفضل إلك 20 دقيقة بالضبط أنه تحكي لنا عن الموضوع. قبل ما أنسى أرحب جدا 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 بالإخوان الأساتذة، كان طالبي وأني دزيت النمسا.
الشرف نعم.
إيه. وأيضا كان طالبي يسوي كان مشاكل هواية، بس مشاكله كانت قليلة. شكرا جزيلا على حضوركم. فالآن رمضان والناس كلكم صايمين، فلا يكلف الله نفسا إلا وسعها. فعندي رجاء يم الإخوان السادة الضيوف، عندنا دكتورة آيتن ماكو عندها فد شغلات كلش مستعجلة لازم تطلع، تسمحون أنه هي تمتحن أول مرة؟ هي هاي السياق.
بكل سرور. بالنسبة لي يبقى الأستاذ.
نعم.
فتفضل.
شكرا.
خلي بس يكمل. يلا أستاذ.
بعد دكتورة
ناهدة
نبدي احنا نبدي، وش وقت ما يجي خليه يجي.
توكل بالله.
Technical application of polygons, sky, ligma and akasha formation. Location of study area. Study areas carried on polygon sky sediment exposed within ligma and akasha formation in western desert of Australian and Paleocene age. The objective the study aims to achieve the following objectives. Number 1, study of mineralogy and geochemistry of polygorskite within Digma and Akasha. Number 2, conclude the genesis of polygorskite. Number 3, report the experimental result on absorption of lead, cadmium, nickel, cobalt, chromium, vanadium, zinc, copper, manganese, iron and boron on polygorskite. Number 4, assessing the efficiency of polygorskite as clarifying agent to absorb and adsorb the heavy metals. Field work and laboratory work. On the field work, as you see here, this is the location and elevation of our sample being collected from this area in the western of Iraq. It has a straight line starting from Tarifawi on the north near the Saudi-Jordanian border to the till the north Akasha, then to Gara. Here is some photo of our field. Laboratory work, sample preparation of stock solution, separation of polygorskite from clay, mineral, X-ray diffraction techniques, random and thermal treatment, ethylene glycol vapor treatment, scanning, electron microscope, SEM, FTIR technique, which is Fourier transfer, infrared, and ICP AES method. We have the mineralogy of raw sample, clay mineral. A clay mineral in our sample include montmorillonite, kaolinite, and polygorskite. And the non-clay mineral included calcium, dolomite quartz, cristobalite, and tridymite, or balcite. Mineralogy of kaolinite. As you see here, the XRD of the whole samples, which shown the kaolinite in SEM here, and in FTIR and in XRD. Plus XRD of the whole sample. XRD of whole sample showing montmorillonite, and then polygorskite. Secondly, this proved that our sample of polygorskite had came through diagenesis of montmorillonite. Then we have the mineralogy of polygorskite. Polygorskite, as you see here in this peak, and in scanning electron microscope, you see the hair-like structure, which is not the polygorskite plus dolomite. Dolomite also present in our targeted sample. Here we have the polygorskite FTIR, and comparing with the standard one, which is the moving one here, the same one, this proves that our sample is polygorskite. Original polygorskite. The two models have been suggested for the origin of polygorskite. First model is reaction of water rich in salicylic acid dolomite, suggests sibyllite form as below. Then sibyllite was transformed to polygorskite by taking Al from surrounding areas. Number two, transformation of smectite to form polygorskite. These are two models of polygorskite. Now we came to geochemistry. As you see here, the 12D is our targeted sample, which we collected, the raw material. Then here we have the separated polygorskite. Polygorskite have been separated through very long procedures, and we are going to give it in detail later on. As you see here, the difference in Al2O3 from the main raw sample and from the separated sample. Here we have the structural formula of separated polygorskite. We calculated the charge of cation on the three layer of polygorskite, which includes the tetrahedral, octahedral, and interlayer. And the calculation also been putting inside table, which is at the last of our project or thesis. Laboratory experiment. Series of adsorption sets were conducted to Kindekbach experiment. It is conducted on these 11 standard solution, which we have prepared on different 10 concentration. That means we have 110 sample we are dealing with. Determination of solid to liquid. The polygorskite maximum adsorption here, as you see, maximum on 1 gram per liter on the concentration of 100 ppm, which is the maximum adsorption result have been taken. As you see, this arrows give it. Equilibrium reaction time. On equilibrium reaction time, we found that the suitable and very nice timing for adsorption is 60 minutes. As you see here, the 60 minutes sorption is on its maximum. Sorption include adsorption and absorption. Then sorption experiment on lead. Here we have the table and the graph. As you see, A is giving the concentration toward adsorption. When the concentration is increased, the adsorption is decreased on this one. Secondly, on C type, this, as you see, the blue one is initial concentration, the red one is the final concentration. As you see here in this, our sample is going to shifting to alkaline after the experiment is dead. Here for cadmium, then for nickel, chromium, cobalt, chromium, vanadium, zinc, copper, iron, manganese, boron. For boron especially, we have some anomalies. This anomalies is due to
concentration of boron. Here the boron. Boron have anomalies like this. We have find that the boron on adsorption, it cannot be governed, or it does not have a trend because of its high, because if it is high atomic number and its concentration also. Sorption efficiency here, we have seen the graph showing the sorption efficiency pH effect on concentration. When concentration is increased, then our solution is going toward alkaline. The effect of ionic potential. Ionic potential, barium looking much more potent on the long series of our 10 samples which we have already prepared, while the sorption is vice versa. It means barium is the less on sorption again. Effect of calcination. Calcination have been done on our sample. Calcination starting from 200 degree up to 800. As you see here, at 800, our sample polygorskite have been collapsed due to loss of all three type of H2O which is present on it. While at 600 degree, our polygorskite is being activated. Conclusion: polygorskite appear as a genetic mineral from transformation alteration of smectite. Reaction poor water rich in salicylic acid with dolomite suggests a sibulite form, then sibulite transform to polygorskite. Strong competition between cation heavy metal negative side on polygorskite occur at high concentrated solution used to decrease sorption efficiency. 3. The decrease of TDS EC value on final solution is function of polygorskite for sorption. Polygorskite sorption. The mass of adsorbent and time reaction at the control factor sorption metal onto polygorskite. The basic mechanism govern heavy metal adsorption characteristics of polygorskite at different pH absorption and ionic exchange. The tendency toward alkaline occur with solution of low concentration rather than solution of high concentration because further cation compete with H ion on H plus on negative side of polygorskite. The ability of polygorskite sorption percentage increase when thermally activated. As we mentioned before, polygorskite can act physically, chemically as absorption for all these minerals which we have chosen in our sample. Thank you for your attention. العفو دكتور.